Thank you, Lynn, for talking about marine ecosystems. But now we're going to switch over and talk about ocean circulation, which is also technically part of the marine ecosystems. So, ocean circulation is the movement of water within our oceans, right? But how is it powered? So, this is powered by thermohaline circulation, which is the global pattern of warm equatorial water. So, this carries heat from the ocean and the atmosphere from the equator towards the poles. And it can be impacted by either completely stopping or being suppressed by global warming. So, how does it work exactly? At the equator, the sun's rays directly hit the water, which warms up the water and causes evaporation and movement, right? So, because the molecules are getting further apart, the water starts to expand towards the north and the south poles, which creates our Gulf Stream, which runs along the Atlantic Ocean. And once this water reaches the poles, it cools down, and because some of the water has evaporated, the density of the salt within the water is a lot higher, right? So this more dense, more salty, more cold water sinks to the bottom of the ocean floor. So this is what they call the ocean's conveyor belt because as the water is sinking, it's bringing oxygen, nutrients, sediment, and a lot of other stuff towards the bottom of the ocean where our decomposers and other animals can use it, right? So this is the global thermohaline paths. As you can see, from the equator, hot water is being pushed towards the poles, and then cold water is being returned back. So if you follow the red lines, you can see that the hot water is pushing towards the poles, and the cold water is pushing away from the poles. But how is this impacted by climate change? So, with global warming and climate change, of course, we have melting glaciers, which we will talk about further in this presentation, right? So, melting glaciers will supply lots of fresh water into our oceans, cold fresh water, actually. So, that causes cold water buildup within the Atlantic and other nearby oceans that are close to the poles. And remember, glaciers are freshwater, and freshwater is less dense than salt water. So, this cold water cannot sink, it just sits at the top of the surface of the oceans. And because of that, this slows down the Gulf Stream or even stops it completely because this cold water cannot be sunk back down and brought back to the equator, right? So this can cause colder weather for Europe and it can disrupt other microclimates as well because the Gulf Stream is not carrying heat towards these parts of the Earth. Thank you so much. And now let's talk about global warming.